Hi everyone, so now we're going to be talking about how to subtract polynomials. And when we subtract polynomials, it's incredibly similar to adding polynomials. The biggest difference is that we have to distribute that negative sign through the second set of parentheses. So the easiest way for me to explain this to you is through examples. Let's just start with one. So the first example is 5x squared plus 4 minus 3 minus 2x squared. Now, in the last video, I said that we could just take away the parentheses because we were adding, and that totally worked. In this video, we can't take away the parentheses until we distribute the negative sign. So notice that there's a minus in between, and that minus isn't just minus 3, it's minus that entire second part of, or that second set of parentheses. And so what we do when we have a minus and then a parentheses, we're going to treat it kind of like, in fact, let me show you with a different color. We're going to treat it like this is not just a negative, that it's a -1. And we're going to distribute the -1 into this second set of parentheses because it's like -1 times that whole polynomial. And when I distribute that -1, all that does is it switches all of the signs. So instead of +3, it becomes -3. And instead of -2x squared, it becomes +2x squared. And so that's all that changes. When we multiply by that -1 or when we distribute that sign, now then the parentheses go away, which means that I can just rewrite the first set of parentheses because the first set of parentheses wasn't multiplied by -1, so we don't need to change anything on the first set of parentheses. We can take the parentheses away, but the signs don't change on the first set. The signs only change on the second set. From here, now we're going to treat it exactly like how we were treating the adding polynomials, which means that we're just going to underline our like terms and then combine. So we have a 5x squared and a 2x squared, and then we have a 4 and a -3. The 5x squared and 2x squared are like terms because they both have x squareds. The 4 and the -3 are both like terms because they both don't have anything. They don't have any x's or any exponents. Once again, we're going to set these up in standard form. So standard form says that the highest exponent comes first and the lowest exponent comes last. So we're going to start with our x squareds because that's the highest exponent. And we've got 5x squared and 2x squared. Well, 5 plus 2 gives me a 7. So it's going to be 7x squared. Now we have the other ones, which are 4 and -3. And 4 minus 3 is 1. So I'm going to say plus 1. And this is our answer. All right, let's go through another example. So the next example is 3x plus 6x to the 4th minus 5x to the 5th minus 7x. Okay, once again, we're going to treat it as if this negative is a -1 because that's what it really is. And then we're going to distribute the -1 into the second set of parentheses. When we do that, all that happens is that the sign switches. So the 5x to the 5th becomes -5x to the 5th, and then -7x becomes +7x. Because the -1 was only distributed across the second set of parentheses, the first set of parentheses we just rewrite without the parentheses. And now we can combine like terms. In this case, we only have one set of like terms, which is the 3x and the 7x, because they both have x's on them. The 6x to the 4th and the 5x to the 5th aren't considered like terms because they have different exponents. So when we set them up, or when we write our answer in standard form, we start with the highest exponent, which is x to the 5th. So we're just going to rewrite -5x to the 5th. And the reason why I can do that is because there's nothing else that I combine it with. So I just rewrite it. Then the next highest exponent is x to the 4th. So we would just rewrite 6x to the 4th because there's no like terms for that. And then the last one is just with the x's. So we have two of those. We have a 3x and a 7x. And 3x plus 7x, we add the two front numbers, 3 plus 7, which gives us 10. And then we tack the x on the end. So our answer is -5x to the 5th plus 6x to the 4th plus 10x. All right, let's go through another example. This example is 7x squared plus. Okay, once again, we're going to distribute that -1. You don't have to write the -1, like you can just kind of write it out like this so that you remember, oh, I'm just going to distribute the negative sign. If it helps you to write the -1, that's totally cool too. So it's going to just change all of the signs. And then that first set of parentheses stays exactly the same. All right, now we're going to underline our like terms. I see a 7x squared and an 11x squared. Then I see a negative 10 and a positive 3. And that's it, because the x cubed doesn't have any other like terms, and then just regular x doesn't have any other like terms. So when we write it in standard form, we start with the highest exponent, which is x cubed in this case. So we're just going to rewrite 7x cubed. Then the next highest exponent is x squared, and we have two of those. We have a 7x squared and an 11x squared. 7 plus 11 is 18, so I'm going to write 18, but then I'm going to tack on that x squared to the end of that. The next highest exponent is just x, which is that negative 8x. There were no other like terms, so I'm just going to rewrite that. And then the last one is something without any x's, which is negative 10 and 3. So when we combine those, it's negative 10 plus 3, which is negative 7. And that's our answer. All right, one more example. This one's a little bit bigger. Okay, so if you notice, we've got 3 sets of parentheses. And in this case, what we're going to do is distribute the negative into this set of parentheses, because the negative came right before that, right? And we're going to distribute this negative into this set of parentheses. So all of the signs flip or switch besides the first set of parentheses, because the first set of parentheses doesn't have a negative in front of it, so we don't have to distribute it. So I'm going to just start by rewriting the first set of parentheses. Now for the second set of parentheses, we're going to flip-flop the signs, so it becomes negative 2x, positive 7x squared, negative 1. And then we're going to flip the signs on the third set of parentheses as well, because the negative came before that too. So it would be positive 3x to the 6, positive 4x, and then negative 3. All right, now we just have to underline and combine like terms. So I see a 4x to the 6, 3x to the 6. I see a negative 1 and a negative 3. And then I see some x's. So I have negative 5x and a negative 2x and a 4x. All right, so when we write our answer, we start with our highest exponent, which is the x to the 6's. We have 2 of those, so we've got 4x to the 6th and then 3x to the 6th. So we do 4 plus 3, which gives us 7x to the 6th. Then the next highest exponent is x cubed. There is that 5x cubed. There's nothing that's a like term with it, so we just rewrite it. Then the next one is x squared. The x squared that I see is 7x squared. There are no other x squared, so we just rewrite that 7x squared. Then the next step is just x's. We have 3 of those, so we're going to add them all together. We've got a negative 5, a negative 2, and a 4. So negative 5 minus 2 is negative 7, plus 4 is a negative 3, so I'm going to write negative 3x. And then the last chunk is the thing with no x's, which is the negative 1 and the negative 3. When I add those together, I get negative 4. So this is my final answer. And there we have it. How to